Hi, this is Kate, and we're comparing and ordering fractions. You may want to have a pencil and scratch paper handy. These two rectangles are the same size and shape. Which rectangle do you think has more of its area shaded? Take a guess, A or B. It's a little hard to tell. Maybe with a hint. Now which do you think has more shaded? You can stay with the same guess or change your guess. Just in case, here's one more hint. Now which do you think has the greater area shaded? You can stay with the same guess or change your guess. Rectangle B with 3/4 had more of its area shaded. Which has the greater shaded area now? Take a guess, A or B. This difference is not so obvious. The shaded regions are actually extremely close in area. In order to determine which is larger, we'll need something more sophisticated than visual estimation. Let's recall what happened with the easier problem. A had 2/3 shaded and B had 3/4. In order to compare the same size things, I drew some additional lines. These multiplied the number of regions by 4. Why 4? Because rectangle B was divided into fourths. B had 3/4 shaded. I drew lines to multiply the number of regions by 3. Why 3? Well, because rectangle A was divided into thirds. Now we can compare 8/12 versus 9/12, and we are sure that B had more of its area shaded. So back to our harder problem. We'll multiply the number of regions in A by 11, because B is in 11ths. We'll multiply the number of regions in B by 7, because A is in 7ths. Now can you decide which has more of its area shaded, A or B? Vote for A or B now. By comparing the numerators, we could see that B had more of these squares shaded, 56 versus 55. So the shaded area in B was greater. Now we can generalize a rule we can use to easily compare any two fractions. To compare A over B versus C over D, we'll multiply both parts of the first one by D and both parts of the second one by B. Let's try this with a numerical example. To compare 4/10 with 5/12, multiply both the 4 and the 10 by 12, and multiply both the 5 and the 12 by 10. Now we can compare 48 120ths versus 50 120ths, and we can tell that the second one is greater. Notice that we didn't actually have to use 120ths. Since 60 is also a multiple of both 10 and 12, we could have used 60ths. This is called using the least common denominator. 120 is a common denominator, just not the least one. But it serves our purposes if we only need to compare two fractions. Now you decide which is greater, 1/3 or 2/5. 2/5 is greater. This is because 2/5 is 6/15, whereas 1/3 is 5/15. We can use our multiplying trick to put fractions in order. First we have to figure out what the denominators all divide evenly into. Can we change them all into tens? Well, there's nothing I can multiply by a 6 to make a 10, so 10 won't work. Since 10 will have to go into anything we pick, let's try 20ths. Can we divide them all into 20? Well, no, there isn't anything I can multiply a 6 by to make 20. How about 30ths? 30ths will work. If we multiply 10 by 3, 6 by 5, multiply the 3 by 10, and multiply the 5 by 6, we can turn these all into 30ths. Turning them all into 30ths allows us to easily compare 12, 35, 20, and 18. Now we can write the four fractions in order. And finally, we can answer the question. In order from least to greatest, we get 4/10, 3/5, 2/3, and 7/6. Now you try. Some scratch paper will help. Take your time and select the correct ordering of 9/8, 7/12, 5/6, and 4/3 when you're ready. In order from least to greatest, the answer is D, 7/12, 5/6, 9/8, and 4/3. If you missed this one, try again. Go back and you should be changing them all into 24ths. This has been comparing and ordering fractions.